Okay, guys. So this is video 2, section 14.7. Example D, here we're going to talk about more advanced problem, mix of both sides. So let me show you how to solve those type of the equation. So we have 4x times x plus 3 equal 4x plus 5. So like you see, this is different because before we had 0 on the right side and then we were able to use zero product rule. Since we don't have a 0, what we're going to do here, we're going to move everything to the left side, trying to make 0 on the right side. Okay. And of course here on the left side, you will actually have to distribute. Okay, so this is different type of problem. So step 1, simplify the left side using distribution property. So again, because I don't have a 0 on the right side, so I need to distribute first. So you're going to take that 4x, multiply by x, and you're going to take that 4x and multiply by 3. So that will give us, we're going to distribute 4x times x plus 4x times 3 equal, and I copy the right side, 4x plus 5. So let's simplify the left side. That will give you 4x squared plus 12x equal 4x plus 5. Okay. Next, what we're going to do, step 2, you want to move all to the left side. To get quadratic equation, in form ax squared plus bx plus c equals 0. So this is what we want to do because we already know how to solve quadratic equation like that. So in our example, we have that 4x squared plus 12x equal 4x plus 5. We're bringing 4x and 5 to the left side. So first we're going to subtract 4x from both sides. So that will give us 4x squared plus 8x equal 5. And one more step, subtract 5 from both sides. And that will give us 4x squared plus 8x minus 5 equals 0. Okay. So now we have a quadratic equation in form ax squared plus bx plus c equals 0. And we know how to solve that. So our step 3 will be factor our equation for x squared plus ax minus 5 equals 0 using AC method. So a is equal 4, b is equal 8, c is equal negative 5. A times c will give you 4 times negative 5, which is negative 20. Next, we're going to find two integers which by multiplication is equal to negative 20. And the same two integers by addition has to give you b. B is equal 8. Okay, so two integers which by multiplication give us negative 20. That will be 10 and negative 2. Also 10 plus negative 2, it's definitely 8. So we have it. Okay. Next, again, still AC method. Since a it's equal 4, so next create two parentheses. Okay, don't forget that. Ax plus first integer times ax plus second integer. Okay, so in our case, a is equal 4, so we're going to have 4x plus the first integer which we find was 10 times 4x plus the second integer which we find was negative 2. Okay, so don't forget that this is not your correct factors. Next, factor out GCF from each parenthesis and ignore the GCFs. Okay, so this is what we have. We have 4x plus 10. That's our first parenthesis. We have to factor out the GCF. GCF in this case will be 2. So let's factor out 2. So that will give us 2x plus 5. And from the second parenthesis, of course, we're ignoring that GCF. That's the AC algorithm. The second parenthesis, it's 4x minus 2. GCF here will be 2. So we're going to factor out 2. So that will give us 2x minus 1. And we're going to ignore that GCF. So the only thing which we're going to keep, it's 2x plus 5 and 2x minus 1. Okay. So the quadratic equation 4x squared plus 8x minus 5, we're going to rewrite this equation using our factors, which is 2x plus 5 times 2x minus 1. Okay, so we have it. And the last step, step 4, solve using zero product rule. Okay, let's don't forget that our quadratic equation is equals 0. So we're solving using the zero product rule, which means make each parenthesis equal 0 and solve it for x. So that's why you need that product. Okay, this one has to be multiplication. So we're subtracting 5 from both sides. We end up with 2x equal negative 5. Divide each by 2. And that will give you x equal negative 5 over 2. That's our first solution. For the second one, we're adding 1 to both sides. We're getting 2x equal 1. Divide each by 2. And you're getting x equal 1/2. That's the second solution. So our final answer, we're going to write down using solution set. The solution set is negative 5 over 2, 1/2. Okay, you can always check if you're not sure about your factoring, but this is definitely correct. Okay, we have a couple more examples. Next, we're going to move to higher degree polynomial equations. So you're going to see x to the power higher than 2. So next one, solving a higher degree polynomial equations. Okay, so this is still section 14.7. So what I'm going to do, I'm going to give you examples and I'm going to explain each example step by step. But this is what we have, negative 6 times x minus 4 times x plus 7 times 2x minus 9 equals 0. So here what we're going to do, first of all, this is perfect, okay, because you have a product and you have a 0 on the right side. So we definitely are ready to use zero product rule. So when you have equations like that, product of factors and 0 on the right side, don't even think about distribute. Okay, so don't distribute. That will be disaster, okay? You'll add extra work for yourself. So don't distribute because we have that zero product rule. You have factors, okay? You have product of factors. You're ready to use zero product rule. Why this is higher degree polynomial? Because again, if I will ask you to factor, you multiply x. You will FOIL here. I will erase that. You guys don't have that. You will end up with something with x squared. And then you will multiply by 2x. That will give you x to the third power. Which again, that we call them polynomial equations when the exponent of variable is higher than 2. Quadratic equation is also polynomial, but those a little more advanced. So here we have beautiful product of all the factors. So we're just going to set up each factor, make it equal 0. But before we do that, okay, first let's just remove that -6. It bothers me a little bit. So first, just divide all by -6. So we're going to divide left side by -6 and right side by -6. That will cancel. And we have x minus 4 times x plus 7 times 2x minus 9 equal 0 divided by -6 is just 0. So now what we're going to do, make each parenthesis equal to 0. So you're solving three equations. X minus 4 equals 0, x plus 7 equals 0, 2x minus 9 equals 0. So we solve the first equation for x by adding 4. We're getting x equal 4. That's the first solution. For the second equation to solve for x, subtract 7. So you're getting x equal -7. Second solution. And for the next one, just add 9 to both sides. And you're getting 2x equal 9. Divide by 2. We're getting x equal 4.5, or just leave it as 9 over 2. So we have three solutions. So our answer, we're going to write down the answer using the solution set. And we're going to list all the solutions. -7, 4, and 9 over 2. So if you will go back to your original equation and you will replace x with one of those three numbers, which are our solutions, you will definitely end up with 0. Okay, so this one was nice. We really didn't have to do anything. We just set up each parenthesis to 0 and solve three equations. Next one, this is a little more challenge. Solving higher degree polynomial equations by grouping. So we talked before how to solve by grouping. Rule number 1, to solve equation by grouping, you should have 4 expressions. Okay, so let's write down note. So use this technique And again, it doesn't have to be higher degree polynomial. It can be also quadratic. Use this technique when you have 4 expressions. Okay, so let me give you the example of solving polynomial equation by grouping. X to the third plus 3x squared minus 4x minus 12 equals 0. So first of all, why we need to solve by grouping? Because we have x to the third power, so this is higher degree polynomial equation, that's one. And second, we have 4 different expressions, okay? So AC method definitely won't work. AC method works only for quadratic equations in terms ax squared plus bx plus c equals 0. So here we need to use grouping. So let's write down the steps. Step 1, group the first 2 expressions. And the last 2 expressions together. By grouping means technically by attaching parentheses. So you not change anything. I just want to quickly put plus between here to make sure that you guys see that there is not a product. We're not changing anything, we just add parenthesis. So we end up with x to the third power plus 3x squared plus the second parenthesis, it's negative 4x minus 12 equals 0. Okay, so very important that you guys see that this is not a product. So we're not ready to use zero product property. Let me just write a note. This is not multiplication. So can't be solved yet using zero product property. And I'm writing this because many times students just see parentheses and they see 0 on the right side and they're just trying to solve 2 equations. No, it has to be a product over there. So when we have those 2 groups, step 2, will be factor out Gcf from each group. You're going to factor out Gcf from each group. So the first group, we have x to the third power plus 3x squared. Okay, we need to find the Gcf here. So Gcf will be, we have x to the third power x squared, so you always pick the variable to the lowest exponent, which will be x squared. So x squared is our Gcf. We factor out, and how you find the expression which will be in the parenthesis, you take the first expression, which is x to the third power, and you divide that by Gcf, which is x squared, and you end up with x. Then you take the second original expression, which is 3x squared. You divide that by Gcf, and we're getting 3. So x to the third power plus 3x squared, you're going to rewrite that as x squared times x plus 3. Okay, so we're going to save that, going to keep it. I will do exactly the same thing with the second parenthesis, which is negative 4x minus 12. Negative 4x minus 12. Since both expressions are negative, your GCF will be negative. I suggest to pick negative number, which will be negative 4. Okay, so we're going to factor negative 4 out, which is the GCF. And to get the expression which will be in the parenthesis, you take your original first expression, which is negative 4x, divided by GCF, which you find, and we end up with x. And then take your second original expression, which is negative 12, divided by GCF, which is negative 4, that will give you positive 3. So in the parenthesis, you have plus 3. Okay, so we're going to keep it. So negative 4x minus 12 is the same as negative 4 times x plus 3. Okay, so we factor out GCF. Okay, and we're going to save those two. Next, step 3. Step 3. Rewrite x to the third power plus negative 4x equals 0 as negative 4 times x plus 3, that's why we factored that GCF, minus right here, because we have a minus, I'm not putting plus, minus 4 times x plus 3 equals 0. Okay, so now this is the equation which we're working with. Okay, we need to factor by grouping. So the whole idea of factoring by grouping is your step 4. Factor out, repeating so what is repeating here? X plus 3. So this is technically the GCF, so we're going to factor that. So that will become x plus 3. Since that's repeating, it's already in front of the parenthesis, times, so you're going to have negative 4, and again we factor that x plus 3, I put it in front of the parenthesis, so the leftovers goes inside the parenthesis. Oops, I'm sorry, I messed up. I put that twice. Go back here. I put that twice. When we factor by grouping, that x cubed plus 3x squared, that will give you x squared times x plus 3. X squared times x plus 3. Okay. Still, the repeating group is x plus 3. So that will give us, when we factor that x plus 3, so when you factor that x plus 3, so what you have left goes in that parenthesis. So we'll have x squared minus 4. And that is equal to 0. Now finally we have product. Okay. When you have a product and 0 on the right side, you're ready to use zero product rule. So step 5. Now since we have factors, use zero product rule to solve the equation. Okay, so we're going to take that x plus 3, make it equal 0, and you're going to take that x squared minus 4 and make it equal 0. You're solving both equations for x. So subtract 3 from both sides, we're getting x equal negative 3. Here, again, isolate. You don't have that bx, so it's quadratic equation, so just isolate x squared by adding 4 to both sides. That will give you x squared and just the square root of both sides. So that will give you x equal 2 and x equal negative 2. Don't forget that when you get the square root, you're always getting positive and negative solution. So we have 3 solutions. Let's write down the final answer. The solution set is, and you're just going to list all of them, negative 3, negative 2, and 2. Okay. And that's it. That was the example how to factor by grouping higher degree polynomial. Okay. Okay, guys, thank you for watching. Send me any messages, any questions you have on email, and we can always catch up or set up the conference and go over those examples.